Today we will be investigating evaporation and intermolecular attractions with two of our GoDirect temperature probes. In this experiment, temperature probes are placed in various liquids. Evaporation occurs when the probe is removed from the liquid's container. This evaporation is an endothermic process that results in a temperature decrease. The magnitude of the temperature decrease, like viscosity and boiling temperature, can be related to the strength of the intermolecular forces of attraction. In this experiment, you will study temperature changes caused by the evaporation of several liquids and relate the temperature changes to the strength of intermolecular forces of attraction. Here we are going to compare two different types of alcohols, 1-propanol and ethanol. We will also need filter paper and small rubber bands. It is recommended that you do this experiment with two GoDirect temperature probes, but it can also be done with one at a time. The GoDirect temperature probes can be connected via USB or via Bluetooth to your platform. Your platform can be a Chromebook, Mac computer, Windows computer, iOS or Android device. To get started, make sure you have downloaded the free Graphical Analysis 4 app from our website or the appropriate app store. Since I will be taking data via Bluetooth, I will first turn on my temperature probes. I will then launch my GA4 app and select Sensor Data Collection. I will connect to my two temperature probes and press Done. For this experiment, I want to change the duration to 300 seconds. To do that, I tap on the Mode button and change the end collection time to 300 seconds. Then press Done. Now that my software is set up, I want to prepare my temperature probes. I wrap a small piece of filter paper around the tip of the temperature probe and tighten it with a rubber band. My propanol and ethanol samples are ready. To begin the experiment, I want a few data points to get a baseline before evaporation begins. So go ahead and place the temperature probes in your solutions. And let them equilibrate for a few seconds, making sure their temperature readings are stable. Then press the Collect button and collect a few data points for a nice baseline for your initial temperature reading. Then remove the temperature probes and place them on the edge of the desk or an elevated surface. Make sure that it's not touching anything. At the end of 300 seconds, the data collection will stop. For each of the liquids, we are interested in the minimum temperature and the maximum temperature. The difference between these two values will give us our delta T, the temperature change during evaporation. To display these values, I can tap along the graph or for a more accurate representation, I can look at the data statistics. First, let me close out of the examine line and then click on the Graph Tools icon and select View Statistics. Temperature probe 1 has a minimum of 10.83 degrees Celsius and a maximum temperature of 21.63 degrees Celsius. Temperature probe 2 has a minimum temperature of 16.07 degrees Celsius and a maximum of 21.65 degrees Celsius. The difference between the minimum and maximum temperatures are my delta T. I can also directly use this delta Y value. By looking at the delta T values for ethanol and 1-propanol, along with their molecular weights, we should be able to predict where the trace for 1-butanol would land on this graph. We can even draw that prediction with the graphical analysis draw prediction tool. First, let's close out of the statistics box, and then from the graph tools icon, select Add Prediction. Using your cursor, draw where you would expect 1-butanol to land. It is not important that you predict the exact delta T value, simply estimate a logical value that is higher, lower, or in between the previous delta T values. I'm going to predict that 1-butanol would land in between 1-propanol and ethanol. I can even name my prediction 1-butanol. And select Save. Now I want to test that prediction along with other chemicals to further explore intermolecular forces. For more information about the Vernier GoDirect temperature probe and our GoDirect line of sensors, visit our website or email info@vernier.com.